Hi, welcome back to the Chicago Math Practice Lab, Learning Through Practicing. Today, we're going to work on our last practice set number 8 from the limits unit. In this practice set, we're going to focus on what is the precise definition of a limit. Okay, when I mean the precise definition is from the mathematical proof point of view. Okay, so here we're going to have 3 different types of the problems. So we're going to practice here. So the first one here is I'm going to give you a kind of the graphs, and then we're going to look from the precise definitions. How do I find what does that means here? Then the next ones here is I'm going to give you kind of a static graph, but I'm also give you a function. Then based on this function, then we're going to one step further to understand what is the definition of what is the precise definition. Then the last ones here is like when I give you a limit statement. So like, for example, limit x approach to 10, 3 minus 4 over 5x, from the previous several practice set, we know, hey, this is negative 5. It's just like limit x approach to 0, x cubed is equal to 0. Then how do I prove it? What is the precise definitions means here? Okay, so that's what is the focus for this practice set here. As always, right now, this is a good time to pause your video and try to work on this by yourself first, and then, resume the video and, can check the answer together. Okay, so now, go ahead, stop the video or pause the video, and I'm going to the whiteboard, and we can start to work on the problems here, okay? Okay, so here we are, and I have put the problems in the whiteboards here. So then we're going to take a look at what is the, what do we mean here. So before we do that, as always here, I'm going to do a brief review. I assume your teacher already show you how, talk about this topic. So what is the precise definitions? Okay, so like we say, like a limit x approach to a, f of x is equal to L, right? So we are very familiar with this notation. That means when the x are getting to a very closely, and then the f of x resulting a limit. So what is the math definition? So basically they tell you, if for every given epsilon greater than 0, okay, then there is a delta, okay, so there is a number delta, okay, so greater than 0, such that, okay, so when the x minus a less than delta, then f of x minus L is less than epsilon. You say, oh my gosh, what's that means here, okay? So don't get scared about the epsilon delta. So basically, they'll tell you is whenever, like when the f of x is getting closer and closer to L, doesn't matter how small you want it. That means for every given epsilon. That means, whenever you want it in this range, then you'll be able to find x value, or you'll be able to find a small enough delta value so the x will exist and will give you this. So you say, I still don't understand. That's fine. So that's why we take a look at these examples. Then I hope that after this full graph, we will understand what I mean here, all right? So, okay, let's take a look here. So for this function here, so for the first functions here, right? So let's say that this is my rule one is my function f of x. So that means when they say for a given epsilon, okay, so now I'm going to say, hey, forever give epsilons here, right? So when x approach to 1, here, right? So when x approach to 1, that means for every given epsilon, so 1, it will become 1. So whenever given epsilons here, so what is the differences here? So this is the 0.2s, right? The differences here. So also from here to here, the difference is 0.2. So what it says here, say, hey, if I want this function close to my limits 1, it's getting close, you know, like it's inside 0.2. So do I have a delta, right? So do I have a delta will achieve this? So now you look here, you say, oh yeah, so in here, whenever, so as you can see, whenever, right, if x is inside my this green area, all the value, whatever. So for example, if this is my other x values here, right? So when the x in this green area, hey, now I will see what happened here. So this distance to the limits is less than the epsilons here, right? So like in here, the epsilon they given is 0.2 here, right? So what is my deltas here? So the delta from this problem, so I will say, okay, delta will be what? Will be the minimum value for the what? For the 0.3 and the 0.1 here. So you say, where is you get a 0.3? 0.3 is from here, right? So the 0.3 is from here to here, is the differences in here, and the 0.1 is from the differences to here. So I know as long as you have, you know, inside this green area, and then you will find, then the difference between the limits will be less than 0.2, right? So in here, what is the delta here is 0.1 here. So that's why, so the delta is 0.1 or any smaller positive values, right? That is what we mean, the precise definition. So whatever you give me, how close you want these limits here, right? How close you want these limits. Then I can always find what? Find the x value inside a certain interval to achieve this. Okay, so now you say, okay, I'm not quite clear, right? Okay, so let's try to do one more. So here, this is the limits. Okay, so this is the limits. I think they're here. Right. Okay, so this is the limit when the x approach to 3, right? So when the x approach to 3, okay, so this is when the x approach to 3, the value is equal to 2. So I'm looking for the differences from the 2 to 2.5 and the 2 to 1.5. So what is the differences here? So this is 0.5, this is 0.5, right? So what is my epsilon here? The epsilon, this problem it give us is 0.5. So you said, hey, can I find the x value or can I find the delta to include this? By look at this graph, you say, hey, yes, as long as this here and this here, for every x value inside this here, I can always find the limits getting closer to 2 and less than 0.5. So for example, like this one's here, right? So in here, hey, I got the limit is less than 0.5 here, right? So for this one's here, so what is my deltas here? Okay, so my deltas here will be what? Will be the minima of what? 0.4 and 0.8, right? So why is 0.4 and 0.8? Because this distance is 0.4. This distance is what? 0.8. So now I will say, okay, so in here, as long as, the delta is in, x is in here, then I can find it, right? So that's why, so the delta is, I can find the delta is equal to 0.4 or any smaller positive values here. Okay, so like, then you will ask, you say, okay, why I take the minimum? Okay, because it's, if you say, okay, I don't want to take the minimum, then what happens here? So here, let's assume if you say, hey, how about the point A? Hey, you say here the point A is in here, my limit is still less than 0.5. Yes, from this side is right. But then if you take a look from the other side, if here, the difference is here, from here is a point A, then what happened here? Then the limits from here to here is greater than 0.5, right? So that's why we take the minimum number for the, for the deltas here, okay? So now let's take a look at the next ones here. Okay, part C, it is a similar problem here, right? But it's a little bit different. They give you a functions here. So then they want you to find it. So for example, for this ones here, the function is y equal to square root of x. So that's why when 4, then y equal to 2 here, right? So now I'm going to find these two limits here. So for first ones here, let me color code this one. So also I know here the differences here is what? The differences here is 0.4, right? So 0.4, right? So what is my epsilon here? Epsilon here is 0.4. Now I'm going to find the deltas here. So delta, just like we color coding, so delta is something here, right? So I need to find these differences. So how do I do that? I need to have the value. The previous graph, they give us the value. So in here, I need to have the value. So 1.6, right? So what is the 1.6? That means the square root of the x for this ones here will give you 1.6. So what is the x here? X will give you 1.6 to the what? To the squares, right? So this is 2.56. So that means for here, for these values here, right? So these values here will give me what? 2.56. Okay, now the same way for 2.4, I know the square root of x is equal to 2.4, right? So what is the x value? X is 2.4 to the square. So 2.4 to the square is 5.76. That means 5.76. That means this values here is what? This values here, this is 5.76. Right, so this is a 5.76. Now, from the previous, I know if this is a 5.76, so what is the distance here? The distance here is 1.76, right? And what is the distance for here? So this is what? So the distance here, this is what? Is 1.44. So just like what we did, so the delta will be the minima of the 1.44 and the 1.76. So what is my delta value? So my delta exists is 1.44, right? So that's what we mean, the precise definition. So let's try one more times here, right? So here, the y equal to the x squares here. So here, this is my limit, 1, the x squared is 1, right? So from here to here, the difference is what? It's 0.5. From here to here, the difference is what? 0.5. So I know from this graph here, my epsilon is 0.5 here, okay? Okay, so now I need to use this function to find what is my deltas here, right? So I need to find the delta, I need to find it here, I need to find it here. Okay, so now let's try. So we said 0.5, right? So the 0.5, let's do the consistency here. So I will say the x squared is equal to the 0.5. So the x is equal to the square root of the 0.5. And so what is the square root of 0.5? It will be 0.7071. So I know these numbers here will give me what? These numbers here will give me 0.7071. 0.7071. Okay, so now the same way, we can do the other one. So the x squared equal to 1.5. So x is equal to the square root of the 1.5. So what is the square root of the 1.5? It's 1.2247 here. So that means this numbers here. So this numbers here is what? Is 1.2247. Okay, so now we can find the distance here. This is what is the distance? 0.2247, right? So what is the distance here? The distance here is 2929, right? Okay, so 2929. So the same way I can say delta is equal to the minima of 0.2929 and 0.2247. So is my delta exist? Yes, my delta exist is what? 2247. Okay. This is how by the graph you can, try to use what we call the precise definitions. Okay. Okay. Now let's go to the last two problems. How about, when they just give me. Okay. So how about, so this is the problem E. Okay. So what do I need to do for the, limit x approach to 10, right? 3 minus 4 over 5 x is equal to -5. We say, hey, what we did before is pretty easy. You just plug the 10 equal to the x, and then you got a -5. So now, what you mean the precise definition. Remember, the precise definition is that for any, okay, so let's see here. So for any given epsilon, right? And then, you'll be able to find, so for any given epsilon, our goal is try to find the delta, right? Just like we practiced for the previous 4 problems. So when we try to do this type of the problems here, right? So we always start with the epsilons here. So this is my functions, right? So let's try to see here, make sure we know. So this is my f of x functions, right? So the way we always start, okay, so the f of x, so the f of x, so the f of x minus L less than epsilons, right? That's our front definitions here. So now let's see here. This is 3 minus 4 over 5 of x. And the limit they tell us is -5. So it's minus -5 is less than epsilon, right? So we always start to manipulate this. We always try to start to manipulate this expression, and hopefully we can try to find what? We can try to find the delta, so such that, so such that we can say this is 0, x minus 10 less than delta, right? Because it will approach to 10. So hopefully this was here. So, okay, so now let's try to see how this one going to happen here. So this will be 3 minus 4 over 5x plus 5, right? Plus 5 less than epsilon. Okay, 3 plus 5. So this is a minus 4 over 5 x less than epsilon here, right? Okay, so now because we want to do x minus 10, so let's see here. I'm going to take this 4 over 5 out, right? I factor 4 over 5 out. So what happened to this term? This term will be x, right? So what happened to this term? If you take the 4 over 5 out, what is the a going to become to? The a going to become to what? Well, maybe I shouldn't skip this step here. Let's do it here, this one. So the a going to become -10, right? So this is -4/5. I factor the 4/5 out, is x here, right? It's just algebra manipulations here. So now the absolute value, I can put this into the 2 absolute value. So this is -10 plus x, the epsilons, right? Okay, so absolute value of negative 4/5 still is 4/5, right? So then here, this is x negative 10 plus x, so you can rearrange it to be x10. So this is epsilon here, right? Okay, now 4/5 is just 4/5, and x minus 10 is less than epsilon. Then what you do is here, you times the 5/4. So this will be x minus 10. We know the absolute value is always greater than 0, right? So this is always greater than 0. Then you divide by, so here, kind of like you do algebra, you divide by 4/5 here, 4/5 here, right? So what happens here? So this will be less than what? 5/4 epsilon. So we say, oh, yes, I got it. So why did I got it? Because the delta, right? So I need to find the delta. So this is my delta. So I said, whenever you find it, you give me an epsilon, I can find the delta. So what is the delta here? Delta is 5/4 epsilon. So I prove it. So I know this limit is correct. Okay? And so you say, okay, I'm still confused. That's fine. Let's try to do one more, right? Okay, so let's try to do this one, the part F here. As hopefully we will kind of know how to do it afterward. Okay, so here, this is a problem F. This is a pretty simple limits, but how do I use the precise definition? This is x cubed equal to 0, okay? So now the same one for every given epsilon, I hope I can find the delta. So that means I'm always start with f of x minus L is less than epsilon for every given epsilon, right? So what is my f of x? Remember, this function is my f of x, right? Okay, so now I will have x cubed. What is the L? What is my limit? 0, right? So minus 0 is less than epsilon. And so I have x cubed less than what? It's less than epsilon, right? So now I can take the x cubed out. So this will be the x to the cube less than epsilon, right? So now what I can do here, so it's x less than epsilon to the what? 1/3, right? So now, because absolute value, so this is x less than epsilon to the 1/3. Based on the definition, I can rewrite this is x minus 0 less than epsilon 1/3, right? So now I can find my delta. So what is my delta here? This is my delta, right? So delta is equal to epsilon 1/3. I find it. So I know limit exists here, okay? And that is what we call the limits of the precise definitions. And if you are the math major, this you certainly need to know this part because this is very, very fundamental to a lot of your proof later here, okay? And for the people who are not in the math major, you gotta just, kind of get a general concept so you know how the limit was defined. So basically, if you want a function get closer and closer to a given value, then you need to be able to find, we call it the interval. So the x can be closer to the value you try to approach to, right? Okay, so that's it. And so this finish our limit unit. That's great. So our next unit we're going to talk about, we're going to expand the limit with continuity and differentiability. So we will see how is the limit progressing to the continuity and differentiability. Okay, so don't forget what do we always say? Practicing, practicing, practicing. That's the way you can get better in the math. And I'm so happy to talk to you about this limit precise definition and looking forward to talk to you in our next unit. Okay? And have a nice day and have fun in maths. Bye.